Okay, all we're going to do is go over the same problem that I had you guys do in class, where we start with 2 points on an exponential graph. We simplify the graph twice until we can find the equation, and then we transform back in order to get the equation of the original. Now the way to start this is to actually just plot the points and draw the original graph. So here we go, I'm just drawing the original graph. It doesn't have to be big at all. I can see it's going to go up, so I'm just going to call this the point 37. And this is the 0.58. And the idea is that's too complicated to find. So what we do is we try to shift this and scrunch it a little bit so that it actually goes to the point 0 something and the point 1 something. Now the first step to do that is to take this point and shift the whole graph to the left 3. And that will actually partially do what we want to do. So I'm shifting to the left 3. This is now the 0.07. And this is now the 0.28. So we're halfway there in terms of getting what we want. This can't be 0.7 and 2.8. It's got to be 0 something and 1 something. Now the way we're going to fix that is we're going to take the graph and scrunch it by a factor of 2 and get something that's nice and easy to look at. So I'm now scrunching. Well, I scrunch by a factor of 2, the 0.07 doesn't move. Yay. The 0.28 turns into the 0.18. Like that. That's now the form that we can write down this really easily. We know we're supposed to write down something like y equals b times a to the x. Remember that b is just the y-intercept here, so that's just going to be 7. A, because the properties of exponential functions, is what we have to multiply 7 by to get 8. Now that's just going to be 8/7. And so that should be the formula, not of the one we want, but of the one we simplified to. I'm just going to check. When I put in 0 for x, I'm supposed to get 7. When I put in 0 for x, I get 8/7 to the 0, that's 1. 7 times 1 is 7, so the first point checks. When I plug in 1, I'm supposed to get 8. When I put a 1 right there, I get 8/7. 7 times 8/7 is 8, and so both points check, which is great. And what we want to do is now work our way back. So we're working our way back. Now what we have to do to our fully answered graph to get the middle graph is now stretch it by a factor of 2. Well, we know when we stretch it by a factor of 2, we're just changing the x because there's no vertical change at all. So this should be something like y equals 7 times 8/7. And I'm thinking it's to the x over 2. I think that's what's going to take this graph and stretch it by a factor of 2. But we will check our answers just to make sure. When I plug in 0 for x, I get 8/7 to the 0. That's 1. 7 times 1 is 7, so the 0/7 still works. When I plug in 2, I'm supposed to get 8. When I put in 2 for x, 2 over 2 is 1. 8/7 to the 1 is 8/7. 7 times 8/7 is 8. So this formula checks. This is actually the formula of this graph. Now, we're going to try to work our way back and get the equation of this graph. We now have the equation of our middle graph. What do we have to do to our middle graph to shift to our original? Shift it to the right 3. Well, we know that, again, changes x. What I need to do is just put in 7 times 8/7, and I think it's going to be x minus 3 over 2. Now, it's certainly an exponential graph. We can check this with Desmos if we like, which is great. We'll talk about that at some other time. But meanwhile, I know that when I'm supposed to plug in 3, I'm supposed to get 7. When I put a 3 in on top, I get 0. 8/7 to the 0 is 1. 7 times 1 is 7, so 3/7 works. I know that when I'm supposed to plug in 5, I'm supposed to get 8. 5 minus 3 is 2. 2 over 2 is 1. 8/7 to the 1 is 8/7. 7 times 8/7 is 8. So sure enough, this is the right formula for our exponential function. The nice thing about doing this, as opposed to doing it algebraically with logarithms and such, is you can see all the original data in this equation. And when you get good at it, you can just fairly write it down without any more work than if you were finding a linear equation.